subscribe and press this bell icon to never miss another lecture video. Welcome to GATE ESE lecture. We are in lecture 10 of signals and system, and this is your first module, continuous time signal, and we are still in the slot of classification signal. In this analysis we are getting into energy and power signal. We are done with the symmetric and anti-symmetric, even conjugate, odd conjugate, all of this stuff, and right now we are getting into energy signals and power signals. For you, let me tell you, it is one of the most important क्लासिफिकेशन सिग्नल्स में जितने भी सारे क्लासिफिकेशंस हैं, सबसे इम्पॉर्टेंट ये टॉपिक है. दिस विल गोइंग टू हेल्पफुल फॉर यू every this lecture video will going to helpful for you every kind of exams, like whether it is a GATE, ESE, PSU, like interview related. It is important, for extremely important. Everything is important, but this part is extremely important. Okay, so please be careful with this thing, and please do finish this thing. Don't skip any of this presentation. Okay, and most importantly, this lecture might get a bit long, and I want you to please complete this entire thing. Okay, it's a very simple thing, and the kind of types and other kind of question types जितना मैं बताऊंगा उतना ही questions आएंगे. Okay, उससे ज़्यादा कुछ भी नहीं आएंगे. Okay, now let's start with what is an energy signal. Basically, the signal which have finite energy are called energy signal. That's it, उतना ही समझना है. Finite energy, which must have finite energy. Now, how to know that this signal does have finite energy? For example, there is non-periodic signals, like exponential signals. All of them are actually energy signals. Now, how to know it does have finite energy value? Okay, so we're going to have mathematical explanation of this definition in the next slide, but for now just try to remember, it gives energy signals gives the finite energy value. For example, exponential signal like e to the power 80 or e to the power minus 80. Okay, all of these exponential signal are non-periodic in nature, so mostly non-periodic signals. Now for power signal, the signal which have infinite energy and finite average power, which is having infinite energy. For if it does have finite energy, then that will be regarded as energy signal. Okay, but if you have infinite energy and finite average power, that will be regarded as power signal. For example, complex exponential signal like e to the power minus j80, and periodic signals like we know sine omega t, cos omega t, all of those things. So now let's do the mathematical analysis of this definition. Look here, there is a circuit which is having resistance R, and you have applied a voltage VT, and the amount of IT is the amount of current which flows through this resistor. So we can say that the power which associated with this resistor, the power which got associated with this resistor is nothing but V square T by R. Yes or no? Or we can say also power is nothing but equals to, in terms of current, that is I square T. It's I square T into R. So it's a very simple fundamental idea. We know this. Power is nothing but a rate in change in energy through this resistor. Okay, now here we can see P is proportional to the square of voltage. P is proportional to the square of current value. Now we can write down this thing. So I can apply a standard definition to this thing. Whatever your function is, if your function is x of t, whether it is current or voltage, that means power is proportional to the square of that function. Now so this is called this is your instantaneous power. This is your instantaneous power for any signal xt. Now as in our analysis, I'm going to include the signals, like complex signals also get included in our analysis. So safe zone में रहने के लिए हम इसको mod ले लेंगे. Clear? So it will give us a safe value, okay, because we are also including the complex exponentials also. Now let's get into the formulas right now. Basically energy is nothing but, how to find the energy value? Energy is nothing but the mod of x of t mod square into dt, and take the overall integral from minus infinity to infinity, from minus infinity to infinity. This is nothing but your energy value, but in a professional way I need to write it down in a like a standard format, that is limit t tends to infinity, that is minus t to t. Okay, in this format also you can write it down, but this is nothing but equals to x of t mod square into dt, that is minus infinity to infinity. It's a very simple thing. Okay, this is how you're going to calculate the energy value. Okay, now look here carefully. What is the interesting part here? Energy is minus t to t, limit t tends to infinity, x of t mod ka square into dt. Okay, now which is equals to nothing but x of t mod square into dt. Now power is rate of change in energy, that is energy by time. Now here in this formula I can't write down like 1 by t. So if I want to write 1 by t, look here, energy's formula is, look here carefully, okay, x of t mod square into dt का whole integration minus infinity to infinity. Now if I do 1 by t, if I divide 1 by 2 to this expression, that will nothing but will going to give me p average or average power. Now if I want to divide 1 by t, listen to this carefully, okay, there will be massive confusion in this case happens, lot of problems happens in the taking of limit. इसको हम बहुत ही गंदे तरीके से लेते हैं और हमको सफ़र होना पड़ता है बाद में. Fourier series, Fourier transform में this thing will going to be extremely useful. Listen to this carefully. When we are taking the limits from minus some lower limit to upper limit, always remember, if you are taking out average power or whatever the value that you are taking out, if average power is actually useful, if you're taking in denominator t, then the lower part, like the amount of interval in which that you are doing the calculation of area, that amount of interval, it has to be t. You understood? So इसका मतलब अगर आप इसको ऐसे लिख लो, minus t by 2 से t by 2 ले रहे हो, that means you are taking in the interval of t. Okay, in that case you take 1 by t, it's okay. Now if you are taking the integration from minus t to t, that means you are taking minus t to t. That means how much, what is the interval? That is, the interval is 2t. So you need to write down here 2t. Understand, clear this concept. इसमें कभी भी confusion नहीं आना चाहिए, because Fourier series, Fourier transform में we are only going to deal with this integration thing. Whatever the limit distance is, whatever the distance that we are covering in our integration, you have to consider that distance in this denominator. Okay, now that you just need to add t tends to infinity. Now this will give you a average power definition. Okay, if you write this is correct, or if you write like this is also correct. Clear? Now let's get into couple of questions which will going to give you fundamental ideas. Okay, this is your power ka expression. You can write down in this way, or you can write down in this way. Now let's get into couple of important formulas through which that we are going to analyze this thing. Look here. The signal is xt. The yellow part is our actual signal. Listen to this carefully, okay? It is very important. xt is my actual signal. Now xt ka mod ka square is our this sky wala part. This sky wala part hai na, sky color wala, that is your x of t mod ka square. Now if you want to calculate the energy value, you need to take the integration of this sky wala part ka. That means you need to find out the area of this x of t mod ka square. Okay, so this will going to give you a finite value. You can see here this is coming out to be a finite, this is coming out to be finite, this is coming out to be finite. Okay, and if you take this x of t and do find out the average power for this, if you do find out the average power for this, 1 by t limit t tends to infinity p average, if you want to find out the p average here, that will come out to be 0. Always remember, whenever you are getting a finite energy value, उसमें आपका average 0 होता है. And here look here, and here look here, yellow वाला है actual graph, that is xt, sky वाला है x of t का mod का square. Okay, now I'm going to find out the area. Okay, area यहाँ पे भी होगा, yes or no? So area, that means this integral is area, so it is extended from, यहाँ पे भी है, infinity में है, so if you add up all the area, it will come out to be infinity. So look here carefully, so area is infinity, that means energy is infinity. Area is nothing but this much, no? So ये वाला जो portion है, when you are trying to calculate this portion will give you a infinite value. That is why your energy is infinite. So when your energy is infinite, उसके बाद आप पी एवरेज को चेक करो. यहाँ पे आपका एवरेज पावर आइदर आइदर फाइनाइट वैल्यू दे सकता है या फिर इनफाइनाइट वैल्यू दे सकता है. इफ योर एवरेज पावर इज गिविंग फाइनाइट वैल्यू, देन दिस सिग्नल विल कॉल्ड एज power signal. If your signal is giving infinite value, then this signal is called as neither energy nor power signal. Clear? Now let's go and check for the average power. If you put the values in the integration, this is the sinusoidal signal, it will going to give you around 1 by I think a square by 2 dega. Okay, a square by 2, the value it will going to give a square by 2, where a is, if your xt is, look, if your xt is a sine t, then the average power, if you do the integration here, like power में xt का value डाल के, you're going to get the value that is a square by 2. Okay, you'll get a finite value. So this is your power signal. So you're getting a infinite value, energy infinite, because area is बहुत सारा. So if you add all of them, it will give you infinite value. But if you want to find out the average power will definitely going to give a value. I want you to do this integration and to find out, you'll definitely going to get a square by 2. Okay, now let's have a conclusion here. So for energy signal, if you take a real exponential signal, यहाँ पे example देखा हम लोगों ने, real exponential मतलब e to the power 80, e to the power minus 80. ओके, मोस्टली ई टू द पावर माइनस 80 में होता है, ई टू द पावर 80 में नहीं होगा. ओके, ई टू द पावर 80 विल नेवर गोइंग टू बी अ एनर्जी सिग्नल. ई टू द पावर माइनस 80 विल गोइंग टू गिव यू एनर्जी सिग्नल, बिकॉज ई टू द पावर माइनस 80 somehow it looks like this, no? So if you do this is e to the power minus 80, if you make the mod and take the square, so and take the integration, it will give you a finite energy value. So that is why it will going to give a energy value. So energy is finite, but average power is 0 for real exponential signal. But periodic signals like sinusoidal signals, complex exponential signals like complex exponential, or sinusoidal signal, so all of them will going to give you infinite energy value and average value, p average is finite. क्लियर? ये कॉन्सेप्ट आपको क्रिस्टल क्लियर होना चाहिए. इसके बाद हम लोग बहुत बढ़िया चीज़ देखने वाले हैं अभी. सो